Today we are learning about probability. This is section 7-4 in your textbook. Our goal today is to be able to find and interpret the probability of a simple event. In order to meet this goal, first we need to look at some vocabulary. The first word we want to define is probability. Probability is the chance that something will happen. And we show probability using a ratio. And as we remember from our unit on ratios, fractions, decimals, and percents are all ratios. Now, probability is measured by looking at different outcomes and comparing them to one another. An outcome are possible results of a probability event. So if we're rolling a die, there are several different outcomes. There's an outcome that we can roll a 1, we can roll a 2, we can roll a 3. Those are all different outcomes. A simple event is an outcome or a collection of outcomes. And random, when each outcome is equally likely. So, for example, for the outcomes to be equally likely, we would have a fair number cube or a fair coin. It is just as likely to land on a heads as a tails, as a 1 or 2 or 3 or 4, etc. Complementary events. Complementary events are interesting. Basically, all that is saying is that when you have an event, one thing can happen or another thing can happen. So if we are, a very simple example is when we flip a coin, you can land on heads or you can land on tails. On the other hand, there are other things that can be complementary events. For example, if we have a spinner and it's broken into 4 pieces, 1, 2, 3, 4, and we want to know the probability of landing on 4. So the probability of landing on 4 is one outcome, and the event that's complementary to that is the probability of not landing on 4. So the probability of landing on 4 would be 1/4, because you have 1 out of 4, and the probability of not landing on 4, there are 3 ways to not land on 4, and that's 3/4. And so we'll come again and look at this relationship. Perhaps you can see that relationship right now. Okay. So the probability of an event is a ratio that compares the number of favorable outcomes to the total number of outcomes. And that would be written like so. The probability of an event is the number of favorable outcomes over the possible outcomes. Just like we were talking about with the spinner example, initially, if we want to know the probability of landing on a 4, the favorable event is landing on a 4, and so there's only one possibility, one possible outcome of a 4, and there are a total of 4 outcomes there. So this is the favorable over possible. Since probability is a ratio, the range of the probability is going to be between 0 and 1. So 0 means that there's no chance, and 1 means that the event is certain to occur. For example, again, if I have we'll just keep using this spinner. 1, 2, 3, 4. The probability of landing on a 5, well, there are no 5s here. So that probability is 0. There is no chance. However, the probability of landing on a number that is less than or equal to 4 is 100%, because every single number on the spinner is less than or equal to 4. So let's try this. We have a spinner, and it's a 6-piece spinner. What's the probability of landing on a 1? So we have a spinner. One, two, three, 4, 5, 6. The probability of landing on 1. Okay, well, there are 6 sections. There's only one way that I can land on 1. And that's if I land in this cube right here. So it would be 1 out of, it's broken into 6 sections. So the probability of landing on 1 would be 1 out of 6, or 1/6. What about the probability of landing on a 2 or 4? Well, I have a 2 here and a 4 there. So there are two possible chances out of 6, and I can reduce that fraction and should to 1/3. You can also do the percentage of 1/3 being 33%. All right, let's look at some other. Okay, so let's find the probability. This is going to be an example of a complement. Again, with the 1 through 6. Of not, so the probability of not landing on a 2 or 4. Okay, well, if the probability of landing on a 2 or 4, you look at the probability of 2 or 4, and it was 1/3. So the probability of not getting a 2 or 4 is 1 minus 1/3, which is 2/3. Okay, so this is an example of finding the complement to an event. This is the the probability of not getting a 2 or 4 is the complement to finding a 2 or 4. So I came up here and found where my probability of getting a 2 or 4 was, and that was 33%. See here. And then I moved up, and I said, well, if I know that I have a 1/3 chance of getting a 2 or 4, then my probability of not getting a 2 or 4 is the opposite. It's 1 minus 1/3, which gives us 2/3. Or if we were to look at our percentages, we had 33% here, and I could say 100 minus 33 gives me 67%. So the complement, looking at the percentage, is 67%. Okay, it's time for the you try. All right, so to win a prize at a carnival, a player has to choose a green beanbag out of a box without looking. Without looking. The box contains 6 yellow, 5 orange, 8 blue, and 1 green. So first I want you to find the probability of a yellow. What's the probability of getting a yellow? Second, what's the probability of getting a blue? And finally, number 3, the goal. What's the probability of winning? What's the probability of getting a green? All right, so to win a prize, we need to pick a green beanbag without looking. We have a total, our beanbags in there are 6 yellow, 5 orange, 8 blue, and 1 green. Find the probability of picking a yellow, find the probability of a blue, find the probability of a green. Go ahead, work it out, and then take a look at the key online.